Hi, future doctors. Welcome to the next class. We were discussing problems on electrostatic potential energy. So already we discussed one problem. Three charges. Three charges placed at three corners of an equilateral triangle. Q, Q, Q. How much work is going to be done? So for this, we discussed initial question to assemble all these three charges. 3 Q square by A. Isn't it? Now, what they will ask me, what is the work done to bring all the charges to another triangle? Same charges we got here. So, from A to A dash, from B to B dash, from C to C dash. So, from bigger triangle to smaller triangle. What is the length of this one? In the inside triangle length is all sides again A by 2. Then, final work done or energy. Same you will get. We take this square by. What you have to write in place of A? A by. Now, what is the work done means? So, final minus initial. What is the final energy if you bring this to upwards? 6kq square by A minus 3kq square by A. So, finally, you people got, how much you got? 6 minus 3. So, 3kq square by A. So, they may give values here. You can do by taking the values. Another problem in this. Now, till now we discussed three charges. Now, we are discussing four charges. The four charges, if you place at four corners of an equilateral means of a square, not equilateral triangle, of a square, of each side, L or small l. Then what is the work done to assemble all these four charges? They will ask. At the time, generally, what we will do means, first we will bring one charge to A. Okay? To bring charge to A, you no need to do any work done because no other charge is present. If you bring another charge B here, now you have to do work done. Why? Because here another charge is there. Now what is the work done to bring charge at B means UB, A, Q into Q by, what is the distance? Next, whenever you are bringing third charge at C, now what is the work done? Now you have two charges. One is at A, another one is at, what is the distance? We have been discussing so many times. Therefore, because of B, A Q into Q by A, because of A Q into Q by root 2A. Now, what is work done to bring charge? Whenever we are bringing charge at D, see how many charges are there? 1, 2, and 3. So, two charges at A separation, one charge at root 2A separation. Therefore, K into Q by A, that's KQ by A. Last one, KQ by root 2A. Now, total work done to assemble all these four charges at four corners is going to be UB plus UC plus UB. Now, how many terms are there? You can see 1, 2, 3, 4. So, 4 KQ square by A. These terms, 2 are there. 2 KQ square by root 2A. Now, what is common? KQ square by A. 4 plus 2 by root 2. Otherwise, KQ square by A, 4 plus 2 can be written as root 2 into root 2. So, KQ square by A, 4 plus root 2. Without solving all these also, we can correct. Means we can done the problem. So by taking the shortcut, even previous problem also. So this problem also initially and finally we can do with shortcut. What is the shortcut means? So total number of pairs and total number of charges. So number of pairs. So what is the equation means? Number of pairs is equal to capital N into N minus 1 by, isn't it? So let us assume in first question you have done 3. How many charges? 3 charges. Then what you got? 3 into 3 minus 1 by 2. Now how many pairs are there? 3 into 2 by 2. 3 pairs. Therefore, direct answer is 3kq square by a. Here also 3kq square by a by 2 because distance is a by 2. Isn't it? Now in this we will see. In this square, how many charges are there? This is for triangle. Now for square we will see. For square, each side of small a. Now total number of charges 4. Therefore, n is equal to how many number of pairs will become? N is equal to 4 into 4 minus 1 by 2. 4 into 3 by 2. If it is cancelled, 6 pairs. But 6 pairs means in that 4 pairs with separation A and 2 pairs with separation root 2A. So therefore, final answer is U is equal to 4 pairs with separation means 4k q square by A. 2 pairs with separation root 2A. Therefore, 2kq square by root 2A. See, final answer you will get. What is the pair separation means? See here. This is A. So it is separated with A 4 pairs and root 2A 2 pairs. This is 1 pair. This is going to be 1 pair. So like this we have to, if it is a square means, now see the pairs I am going to draw for you for your convenience, how you have to take fastly. Q. Now see, separation is going to be A. Now 4 pairs I said with separation A. So what is this 4 pairs means now? This is 1 pair, this is 1 pair, this is 1 pair, and this is 1 pair. Total 4 pairs with separation A. Now another 2 pairs you can see. This is 1 pair with root 2A. This is another pair with root 2. So finally 4 with A, okay, 2 with root 2A. Like this they are going to ask. Okay, at the time you can solve very easily. Just if you remember number of pairs. So, but number of pairs will be useful only for cube. So if they ask cube means we will do, otherwise we won't do. Next, on this only they will be asking like this. So Q, capital Q. So to get electrostatic potential energy 0, how much charge we have to place? Capital Q. A, B, C. How much charge we have to place at C to get electrostatic potential energy 0 they will ask. At the time how we will do means very simple. So this is A means this is not equal to triangle. This is going to be root 2. You have to place how much charge here to get electrostatic potential energy 0 means first term. This is 1 pair, this is 1 pair, this is 1 pair. Therefore total U is equal to K, small q into capital Q divided by small q into small q together plus K q into q by A. Here plus capital Q into small q divided by root 2A should be equal to 0, isn't it? So this is 2 times 2, not 2 times. This is only 1 time. You can bring this one that side. Correct? So capital Q. So you can bring this one that side. You are going to get the answer. We'll see. What is common among all these? What is common means KQ by A, KQ by A, KQ by A. It is going to become 0 if you bring that same. Now what is remaining here? Here capital Q plus small q. Here capital Q by root 2 equal to 0. Correct? Now we want capital Q. So capital Q, if you have taken common, 1 plus 1 by root 2 is equal to minus. If you are bringing this one that side, so Q is equal to minus Q by 1 plus 1 by root 2. Correct? Minus Q by root 2 plus 1 by root 2. So you can bring this one numerator and capital Q is equal to minus root 2 small q by root 2 plus 1. Final answer may be like this, otherwise, so they will do rationalization sometimes. So root 2 minus 1 by root 2 minus 1. At the time, minus root 2 into root 2 minus 1 q by, so a square minus root 2 into root 2, 2 minus 1 into 1. Therefore, final answer is minus q root 2 into root 2 minus. So like this, they are going to ask. Same like this, they are placing three charges, small q, capital Q, again small q. Separated distance A, separated distance A. So what is the capital Q? What is the capital Q? To get electrostatic potential energy, 0 they will ask. At that time, what we will do means, again same process. This separation, and this separation. That is going to be, so K into small q into Q by A plus K into capital Q into small q by A with separation plus, now what is the last one? Last one is going to be K into Q by 2A. See here, Q into Q, this total separation is going to be 2A equal to 0. Now see which are going to be cancelled common. K Q by A, K small q by A, K small q by A is 0. Cancel. And what is remaining here? Q plus here, Q plus small q by 2 equal to 0. Then what we are going to get here? Q plus Q. 2Q is equal to minus Q by 2. So Q is equal to minus Q by 4. So if you place minus Q by 4 here, total electrostatic potential energy will be 0. Like this they will ask. In next class, we will discuss only cube. Cube they won't ask in NEET exam, but we will see how to solve by using shortcut. Okay.